So the problem that we're solving is this one. 2 over x plus 1 plus 1 over 3 is 1 over x plus 1. So when you look at this, just like in that video that you watched, what you want to do is you want to say, what is in the denominator? So I look to see what's in my denominators. And in the denominator, I have the x plus 1 right here. And the other thing I have in the denominator is the number 3. Then I look at the other side of the equation, and all I have there is x plus 1. I already counted x plus 1 once, so this has already been accounted for. Do not count it twice. If you count it twice, you're just going to make make it harder for yourself. Okay, so don't do it. If you count it once, don't count it again. So you say whatever's in the denominator. So that was step 1, which is where we determine what's in the denominator. Then the next step is you multiply every single term by what was in the denominator. So I come in the first one, I have to multiply it by 3 times x plus 1, by 3 times x plus 1 times 2 over x plus 1, plus I also have to multiply the second term by what was in the denominator, and that is 3 times x plus 1 times 1 over 3. Okay. And, you know, you can put a dot here or not put it. When you put them next to each other, it means that they're being multiplied. And the last one, we do the same thing. 3x plus 1 times 1 over x plus 1. Okay. So now I have multiplied every single term by the product of what's in the denominators. If it was repeated, I don't need to do it twice. Now the next step, so this was step 2, where you multiply by the product of the denominators. And now in the next step, which would be our step 3, we cancel the like terms. So here I've got x plus 1, here I've got x plus 1, they cancel. Then here I've got 3 times x plus 1 times 1 over 3, the 3's cancel. And here I have an x plus 1 in the denominator, and I'm multiplying it, so those all cancel. You should not have any denominators at the end, because everything in the denominators should cancel. If they don't cancel, you've probably missed something. Okay, so now let's see what's left. 3 times 2 is 6, plus, here I just have x plus 1 and 1, so I have x plus 1, equals, these two canceled. On this side, I only have 3. Okay. And now in the next step, step 4, we're going to solve it. So in step 3, we canceled. And in step 2, we multiplied by the denominators. All right, so now I'm going to add the like terms to each other. I have a 6 and a 1 over here, so I get x plus 7 equals 3. And then I'm going to subtract 7 from both sides. And I get x is equal to 3 minus 7 is going to be, so you subtract the 2, and you get 7 minus 3 is 4. And you put the sign of the bigger number, so x is negative 4. Now, it may appear that I'm done with this, but I'm not really, because once you get your answer, you have to check it. So the last step, which is step 5, is you're just going to check. And what are you checking? Make sure the denominator will not be 0. So that's what you have to check. You make sure that when you substitute this number back, the denominator is not 0. So if I go over here, I've got my denominators here, so I can check here or I can check here. If I substitute negative 4 in for x, I get negative 4 plus 1, that's negative 3. Well, that's not 0. There are no x's here, so that's never 0. And this is negative 4 plus 1 is negative 3, so it's not 0. So once you get to that, you say, you give your answer. X is -4. And how do I know this answer is correct? Because when I substitute, I don't get 0. If I substitute it back, both sides of the equation should be equal to each other.